Hello and welcome to Cambridge Clinical. In this video, we'll be discussing questions in the decision-making section that assess your ability to calculate and deal with probabilities. Before delving into a few example questions, it's probably best to start with the most basic theory. So when calculating the probability of a single thing happening, the probability of that is the total number of ways in which it could occur over the total number of outcomes that are possible. So to make this picture a bit clearer, let's use a real-world example. So let's say the probability we're looking at is that of rolling 6 on a dice. So first of all, total number of ways in which this can occur. How many is that? Well, given it's a normal dice, there's really only one way in which you can roll a 6. So now let's think of the total number of possible outcomes. Well, given every time you roll a dice, you could in theory roll one of any of the 6 numbers on that dice, there are 6 potential outcomes. And so that gives us the probability of 1 over 6. So let's do another example with the dice then. This time let's think of the probability of rolling anything except 6. So first of all, let's think of how many ways could this occur. Well, there are 5 ways this could occur. You could roll 1, 2, 3, 4, or 5, and that would still be anything but a 6. So now how many total outcomes are possible? Well, once again, it's 6 total outcomes, because every time you roll a dice, you could roll 1, 2, 3, 4, 5, or 6. And that therefore means that the probability of rolling anything but a 6 on a dice is 5 over 6. Let's move on now to dealing with something a bit more complicated, which is dealing with probabilities of multiple things occurring. So first of all, when calculating the probability that either of 2 discrete things occurs, we add the probabilities for each thing. So I've called them P1 and P2, but we'll make an example of it to make it clearer. Returning to this idea of the dice then, let's ask ourselves, what is the probability of rolling either a 6 or a 4 on a dice? So in this example, P1 will represent the probability of rolling a 6, and P2 will represent the probability of rolling a 4. Thinking back to those earlier examples, we worked out that the probability of rolling any digit on a dice is 1 over 6, given there's only one way it could occur and 6 total outcomes. So we can say the probability of rolling a 6 is 1 over 6, and the probability of rolling a 4 is 1 over 6. Therefore, the total probability of rolling either a 6 or a 4 is 1 over 6 plus 1 over 6, which gives us 2 over 6. The other slightly harder probability questions are those that ask you to calculate the probability of both of 2 discrete things occurring. And so for this, we multiply the 2 probabilities together. So once again, returning to the example of the dice, we can ask ourselves, what is the probability of rolling a 6 and then a 4 on a dice? Or in other words, rolling both a 6 and a 4 in one turn. So as before, we know that the probability of rolling a 6 is 1 over 6, and the probability of rolling a 4 is 1 over 6. Therefore, the probability of rolling a 6 and then a 4 is 1 over 6 times 1 over 6, which gives us 1 over 36. So now that we've covered the theory, let's see if we can apply it in a practice question. So this one reads, Jeremy's music player randomly selects a song for him to listen to. The music player has 8 rock songs, 5 classical songs, and 2 folk songs on it. Will Jeremy increase the chance of listening to classical songs if he deletes one song of each of the 3 genres from his music player? So why not pause the video now and see what you think? Well, as we discussed, to calculate the probability of any one thing happening, we need to think of the total number of ways in which it could happen and the total number of possible outcomes. So for this, the total number of songs is 15. So given there are 8 rock songs and 15 total songs, the probability of choosing a rock song is 8 out of 15. Similarly, there are 5 classical songs, so the probability is 5 out of 15. And there are 2 folk songs, so the probability of choosing a folk song is 2 out of 15. Now, when we remove one of each, we're removing 3 songs in total. So the total number of possible outcomes reduces to 12. For rock, 8 becomes 7. For classical, 5 becomes 4. And for folk, 2 becomes 1. So what we now need to do is compare the probabilities before and after removing the songs for classical, as that is what we're asked. To compare probabilities, or any 2 fractions, we need to convert them into having the same denominator. So the lowest common denominator here is 60. And when we convert both of these probabilities to being out of 60, they both come out as 20 over 60. So now that we've worked out each of those probabilities, let's refer back to our answer options. So it says here, A, yes, the likelihood of listening to a song of a particular genre increases when the total number of songs decreases. B says, yes, the likelihood of selecting a classical song is higher when there are fewer rock songs and folk songs. C says, no, the chance of selecting a classical song decreases when the total number of songs decreases. And D says, no, the chance of selecting a classical song remains the same when one song of each genre is deleted. So why not pause the video now and see if you can work out which one of these is correct. So given the probability both before and after removing one song of each genre is 20 out of 60, we can definitely say that Jeremy does not increase his chance of listening to a classical song. So we can rule out A and B instantly because they both say, yes, the likelihood is increased. Out of the remaining 2 answer options then, it's D that uses the correct logic. It says the chance of selecting a classical song remains the same, and that matches with our logic, which showed that both before and after the probability was 20 out of 60. So that concludes our video on probabilities. I always suggest trying to calculate your basic probabilities before getting too sidetracked with the answer options. And so long as you remember the basic theory rules we've gone through, you should be absolutely fine.